All right. This lesson is for the exponent properties. Sorry. Part 1. Okay. Again, please take notes. I'll be able to use them later. So exponents, there is a number, and that number has another number on the shoulder, right? Call these exponents, right? But here's how I want you to write it. I want you to write a B and then an E, all right? And what that stands for is, let's say that you have 2 to the third power, okay? This, my friends, is called the base, okay? Because it's all about that base, so you have no troubles. This right here is called the exponent, okay? Need you to write this down, copy it down, all right, in your notes, different colors, highlighted, do whatever you need to do. So it's called a base and it's called the exponent. Very important because we're going to be referring to these over and over again. And you need to understand the language, right? I'm going to say something like, hey, what is the base of this particular exponent? And you got to be able to tell me, okay? Because otherwise it's going to get a little confusing, okay? Now, I think most of you guys already experience exponents, right? So, for example, if I say x to the second, what that really means is x times 2, right? Wrong. This is the number one mistake the students make all the time with exponents. They want to multiply the base and the exponent together. Please don't do that, okay? Like when I say 2 to the third, number one mistake is 6. Please don't do that, okay? That's not what that means, right? What this really means is x times x, the base, multiply with the base, however many times the exponent tells you to do it, right? So if I say x to the third, that would be x times x times x 3 times, right? So if we know this, and I say to you, well, what if I say x squared times x cubed, which is the same thing as saying x to the second times x to the third. What that means is, right, x times x times x times x times x, right? This first part represents the square, and the second part represents the cube. But at the end of the day, when we are multiplying 5 x's together, you get x to the fifth. Right? Now, here is what I want you to notice. Was there a shortcut that we could have taken? And hopefully most of you could see it. Oh yeah, Mr. C. I could have just added 2 plus 3, which are the exponents. So this is a property of addition for the exponents that we need to know, right? Exponent properties. And this one is the addition property of exponents, which says, hey, if the bases are the same, then we can go ahead and add the exponents together. Now, if the bases were not the same, like x squared times y cubed, you can't do it because these two bases are not the same. Okay, so you can only do it when they're the same base. Now, let's say that you have something like example number 1. Okay, you go ahead and try to do it. x to the third times x to the 10th. Did you get it? Shouldn't take too long. Like, all right, it's pretty easy. I can add the exponents and I get x to the 13. That's the same thing as multiplying the base. We're cool with that? All right, let's make it a little bit more difficult now, okay? What if I was like y to the second times y times y to the fourth? Go ahead, pause the video and see if you can do it. All right, I'm gonna assume that you already paused and that you got it done. 2 plus, and a lot of people don't see this, but when you have a base by itself, the exponent is not a 0. A lot of people are like, "Wait, I don't see it, so it must be a 0." No, when you don't see it, the exponent is actually a 1. Okay, and is an invisible 1. So go ahead and dot it, and that is 1, right? Because you got 1 y, right? So 2 y's times 1y times 4y is the same thing as adding those exponents, which at the end of the day, you get a 7. So watch out for this blank or invisible exponent, I should say. Okay, watch out because it's going to show up over and over again. Let's try another one. Okay, try another one. Example number 3. Okay, again, you do it on your own first, and then I'll help you out. X, y to the third times x to the fifth, y. Yeah, and that's it. Pause the video and try it. Now, I'm going to guess that you paused it, you try it, if you have an answer. Let's see what you get. So, the x's with the x's, the y with the y's. Now, again, this x has an exponent of 1. So, that should be 1 plus the x to the fifth, which is the 5, right? The y has, the first one has an exponent of 3. The second one has an exponent of 1. So at the end of the day, you should have x to the 6th, y to the 4th. We good? Right? Now let's go ahead and add some coefficients to this. Let's add some numbers. For example, 2m to the third n to the fourth times 3m times 4n to the, let's go with to the fifth, right? So pause the video and try it. I'm gonna I'm gonna assume that you tried it. So the best thing you can do is organize yourself. You got the 2, you got the 3, and you got the 4. So let's go ahead and put those coefficients together. Okay. Then we'll take care of the m. And let's look for all the m's that are there. Right. So go ahead. I took care of the coefficients. Now I'm going to take care of the m. I see another m. So that's a 3 plus a 1. Okay, I took care of the m's. Now I'm going to take care of the n's. Like, oh, okay. Times n to the fourth plus to the fifth. So I took care of everything. It's really helpful that you make it very organized. Okay. Now that you've done all of that, let's do the multiplication of the coefficients. 6 times 4 is 24. And then I'm going to go ahead and take care of the m to the fourth and the n to the ninth. And that is my final answer. Okay. Let's throw some negatives in there just to make it fun. Example number 5. Negative 5, x to the 4th, y to the 5th, times 2x times y to the 4th. All right, go ahead and check it out. See if you can do this on your own. Okay, I'm going to assume that you paused. I'm going to tell you how to do this. Again, you got the coefficients, which is negative 5 times 2. Got the x's, which is x to the 4th plus 1. And then you got the y's, y to the 5th plus the 4th. At the end of the day, you get negative 10 x to the 5th, y to the 9th. And I believe that is your final answer. Oh, let me do that again. All right, we're good. That's just as the but this one, example number 6. Let's say you had 4x to the 5th, y to the 7th times negative x, y to the 8th. Okay. So let's say you have something like that. Oh, and then times z. Yeah, let's kill a couple of birds in one stone. So again, I got the 4 times, guess what? The negative, because that negative is not just a negative. That negative is actually a negative 1, and it's an invisible 1. So that's 4 times negative 1. Okay. Let's just remember that. All right. So now that we take care of the numbers, let's take care of the x's. X to the 5th plus 1. Because again, we have a 5th here, we have a 1 here. Not the one in the front. No. That one's already here. Okay, that's the exponent. And then we got the 7th and the 8th, which is y to the 7th plus 8. And then we have this z chilling. So since he has nobody else, we're just going to leave it as z. Right. So then I'm going to go ahead and multiply these two. I get negative 4 x to the 6th, y to the 15th, and then z, which is just chilling. And that is my final answer. Now, I'm going to put a different title for the next part. And I'm hoping that you will understand this. Let's say that you have x squared, and then that is the base to another exponent, x to the 3rd. So what does that mean? This means that, again, remember the base. This is the base, and this is the exponent. And it's telling me to repeat the base 3 times. Which means this is 2 plus 2 plus 2, which is really x to the 6th. Well, was there a shortcut that I could have taken? Hopefully, yeah, Mr. C, you could have, right? Multiply these two, and what do we call that? We call that distribution. Distribute the outer Is that with two T's? So bad. I think it's two T's. Okay. Distribute the outer exponent. And again, this is different than this one, right? This is two bases with their own exponents, as opposed to this one. So one base with another exponent on the outside. Okay. So let's say you have something like x to the fourth to the fifth. What would that equal to? Pause the video. Now, hopefully you multiply these two and you said, oh, okay, that's pretty easy, x to the 20th. Good. What about this one? X to the fifth, y to the third, to the second. Go ahead and pause the video and check out to see if you can do this on your own. So hopefully you distribute it to every exponent. Okay, every base has an exponent. All right, and that one is x to the 10th, y to the 6th. Right? And there's some tricky ones, like this one. X, y to the 4th to the 5th. Oh, that was. Now, you're thinking, okay, I'm going to distribute just like I did before. Here's the thing. A lot of students only distribute to the 4 because they're like, well, I don't see anything on the X. Remember, the X has an exponent of 1. It's an invisible one, but it's still there. So you must distribute to both, and you get x to the 5th, y to the 20th. Okay. But a lot of students, again, they do mess up. They don't do it right, and they just do this, and they leave the x by itself, and they think that this is correct. This, my friends, is not correct. Okay, it's incorrect because the x has an exponent of 1. So make sure that you take care of that. Okay, let's make it a little more difficult. 5x to the 4th, y, z to the 3rd, to the 2nd. Pause and see if you can do this on your own. Okay, so hopefully you remember what I said. Every item in that parentheses is a base and it's got its own exponents. The 5 has an exponent of 1. The x has an exponent of 4. The y has an exponent of 1. And the z has an exponent of 3, which means you have to distribute this 4 times. Everybody has their own exponent. 5 to the 2nd, x to the 8th, y to the 2nd, z to the 6th. Right? 2 times 1, 2 times 4, 2 times 1, 2 times 3. Now the numbers, you got to multiply them out. 25, x to the 8th, y to the 2nd, z to the 6th. We're good? Now let's go ahead and combine the addition property with the distribution property. So what does that look like? Number 1. x to the third second times x to the fifth. Right? So what does that mean? Oh, I gotta distribute, always distribute first, x to the sixth times x to the fifth. And then now you're going, oh, okay, I got two bases, and I can go ahead and add the exponents. And that's my final answer for this particular problem. Okay, you distribute, always distribute first if you can, always. Let's make it a little more difficult. Okay, check it out. Let's say you have x to the third, y to the fourth square times x to the fifth, and then y. Right? So pause the video if you want, but here's the solution. I'm going to go ahead and distribute again. I get x to the sixth, y to the eighth times x to the fifth and y. Well, let's go ahead and take care of the x terms together and the y terms together. And according to what I see, the exponents are 6 plus 5 and 8. Oh, snap, hang on. 8 plus 0. I'm kidding. It's 8 plus 1. Okay, remember that. Don't forget. X to the 11th, y to the 9th is your final answer. Okay. Now let's make it super complicated. Or maybe not that complicated. M to the fifth second times M third to the fourth. Pause and try. I'm going to go ahead and distribute twice. I get M to the 10th times M to the 12th. And now I'm not going to distribute, I'm going to go ahead and add. There's a difference, right? Because I have two separate bases that are the same, but I have two. I end up with M to the 22nd. Okay. Now, a couple of things that you got to be aware of. Distributing to negatives. Okay. So watch out for these. Let's say, for example, I have negative 2 M to the third and the second. Let's go to the fifth. And let's go to the fourth. Or let me see what your homework says. Yeah, fourth is fine. So I'm going to go ahead and distribute that to the 1 right here, to the 3 right here, and to the 5 right there. Now, that means, and make sure that the negative 2, if it's a negative, you should put it in parentheses. It's always helpful. Put a 4 right there. M to the 12th and to the 20th. Now, what does it mean for this one? That means is negative 2 times negative 2 times negative 2 times negative 2, which equals to 2 times 2 times 2 times 2 is 16. And negative times negative times negative to negative. That's 4 negatives, which is an even number of negatives, which means it's positive 16. M to the 12th and to the 20th. Okay. Had it been 3 times, if it was 3 times, it would have been a negative answer. would have been -8. But if it was 4, because it's 4 times the positive. Okay. I believe that should cover you. Watch out for this as well. Negative m to the fifth and to the fourth to the third or something like that. Now that negative in the front is actually a number. And that number is a -1. So that -1 deserves a third, right? M to the 15th and n to the 12th. I did this so that you can really watch out for that. Okay. -1 times -1 times -1. There's 3 negatives, which means my answer is going to be a negative. Okay. That's it. Hopefully this is not too difficult. It's going to get more difficult later, so make sure that you take care of this and take good notes.